Can we get the slides up?
Cool. Right. Hi, everybody. My name is Jacob. I work on a bunch of different things, and a lot of those things recently switched to CalVer over the last couple of years, and now I'm very sad. Now, this talk has been adapted from a blog post that I wrote earlier in the year. If I run out of time and get clapped off the stage, go and read the rest of the blog post. I promise it's really interesting. Take a picture of that if you want to go and have a look. So, calendar versioning is something of a trend, it seems, within our community, especially in like the scientific Python community. I see lots and lots of projects moving this way. And I kind of want to just warn everybody and say there's lots of consequences of doing this, so please don't necessarily just jump on board with everyone else. So just in case you have no idea what I'm talking about, semantic versioning is when you have a version where the numbers mean things, right? And typically in semantic versioning, the first number is, I'm going to break something. If I increment this number, you can't safely upgrade. You have something to do. The middle number means I've added something interesting. You might want to check it out, but you should be safe to upgrade. And the third number means we've fixed something. You probably do want to upgrade. Now, like every bug is somebody's feature, so this isn't always true for every single reason. Whereas calendar versioning is just, it's the date. This is the date that I made this software. Good luck. I wish you all the best. If you ever want to upgrade in the future, I wish you luck on that day as well. Now, it's quite common to either do year, month, day, or if you want to have the ability to release twice in one day, you do year, month, patch, which is just a monotonic number that goes up. And in Dask, which is a project I work on a lot, in 2020, we switched over to calendar versioning. So we went from 2.3.1 to 2020.12.0. And this was done for like a bunch of different reasons, and all of those reasons felt really good and really valid at the time. But one of the things that we kind of lost is the fact that version numbers are a way to communicate to your users. And we just abandoned that. We just said, we're not going to tell you what we're going to change. We're just going to change stuff, and we wish you luck. And I kind of feel sad about that these days. So what I'd really like to impress on people is that libraries and APIs, things that people really depend on tightly in their code, should be semantically versioned. And I don't necessarily mean like actual semver that's really rigid and people get upset about how rigid it is. But I just mean communicate to people through your version numbers what you're going to do, at least give them a heads up, give them some information. And some projects like Django and Pandas do this. Pandas recently had a big 2.0 release that everybody's kind of very excited about, but it was very clear that there was lots of breaking changes in Pandas 2.0. On the other side of that, there's a totally valid time for calendar versioning, and that is in distributions. The one that everybody's probably seen is Ubuntu, right? Ubuntu is a distribution, it uses calendar versioning. It's just a big collection of bits of tools and software and stuff, and they do their best to test that each release of Ubuntu works. And on that date, they can kind of guarantee that all of those things work. And at some point in the future, they may not work, and they change things, and then they increment the numbers, right? And also, if you're in the scientific Python world, Anaconda have a distribution of lots of Python libraries. Again, this is also calendar versioned. But I kind of want to give away the secret, is Ubuntu isn't actually calendar versioned. It is semantically versioned. They do include semantics in their version. If you go and read what their version means, they say, we release in April, we release in October. Each one of those is a major release, and then the patch number increments as we fix bugs. Oh, look, actually, it's major patch, right? It's not calendar versioning. They felt the need to add semantics to their version. Okay, we followed in Ubuntu steps. We held them up as a big example in Dask of, this is a great thing to do. We should, Ubuntu does calendar versioning. And if you've not used Dask before, Dask does feel like a distribution in many ways. It implements the Pandas API. It implements the NumPy API. It implements the scikit-learn API. It feels like a collection of other things. It did feel like a reasonable thing to do at the time. And I don't necessarily regret Dask going, oh, I don't want adverts getting in front of my timer. It felt like a reasonable thing to do. But there's loads of other sub-projects in Dask that are more APIs. We have lots of different tools. We have a distributed scheduler. We have lots of different things that are just Python code. It's a library. It has an API. We moved all of those to calendar versioning, and I really seriously regret that. So a few more points that I probably can't get through in this talk because I've got like less than a minute left. But all of this is in that blog post. If you just go to my website, jacobtomlinson.dev, you can go and read the rest of this post. But like, people assume that calendar versioning gets you into a habit of regular releases. It doesn't necessarily. Moving back can be hard, right? Python does have a way of doing this with epochs, but if you've ever tried using them, they don't behave how you expect them to behave, and your users will be even more confused in many situations. Calendar versions are not notable. They're not... if a new version comes out, it's just not clear to people what's in it, what's happened, what's changed. Is it a huge change? Is it a tiny change? And so sometimes people just put meaning in where there is no meaning. Oh, we've moved to a new year. There must be lots of new changes. The big number at the beginning is updated. And it's like, no, we're just saying Happy New Year. So that's it. Calendar versioning is great, but please be careful. Thank you.
Try it here and it's not.
Okay, thank you very much, Jacob. In fantastic news, Hinnick is having trouble setting up on that lectern, so we're going to try the same thing on a lectern over here. So that's second speaker already. I have some notes for stuff to talk about in between. So after the lightning talks this evening, we're going to have a half-an-hour break, and then we're going to have the board games and manual technology night. I think that's downstairs. Apparently that's a yes. And that's just, it's kind of self-organized. There's going to be a bar. There's going to be Pie Minister outside. If you haven't experienced the pies of Pie Minister, then I think you're in for a real treat. It's a great way to meet new people. There will be tables with board games, tables with knitting, crochet. I will teach you to tie a knot called a monkey's fist, if you like. So yeah, there's going to be a bunch of stuff going on. How are we doing? 30 seconds. Okay. I stepped outside my front door the other day, and somebody on a tractor drove past really fast, shouting, "The end of the world is nigh!" I think it was Farmageddon. This is why they gave me 2 lecterns to try and stop me from telling tractor jokes, but that just doesn't work because there's always problems with the technology. Was that 30 seconds? Are you okay? We're happy. Okay. So who are we going with? We're going with your side? You can go. Okay. So I am going to introduce my friend Hinnick. You may know him from his talk, I Love CalVer, that he's given at a few conferences in the past. He's going to give us a talk called SVCS, the most exciting Python package of the past 42 days. So if you give him a big round of applause, please.
All right. Hello. I want to tell you about my latest project that I'm legit excited about, and it's called Services. It's spelled SVCS because it looks cooler, it's shorter to type, and it was free on PyPI, which is the actual reason. It is released under CalVer, and I regret absolutely nothing. Unfortunately, it is very hard to talk about the concepts it's using because the space it operates in is full of jargon. So like the correct term for it is a service locator. Does anybody know what it is? I did not. I implemented that, and then I saw on Wikipedia what it is. So practically speaking, it is a helper to manage services on request objects. This is not entirely true. It does a lot more, but this is a good way to get started. Now, this is still jargon. Like, what even is a service? It can mean everything. It can mean absolutely nothing. So in the context of my package, a service is a configurable runtime dependency that makes testing harder. So in web frameworks, it is a database connection, a web API client, or a web-scale data shredder like MongoDB. So basically things that interact with the outside world. And talking about all of this in abstract is a pain in the butt, which is why I talk about it in terms of web frameworks. And because Flask's dependency management, or the lack of it, was the reason why I started writing services, I will use it as an even more concrete example. So I'm sure everyone who ever used Flask knows this pattern. You define a get something function for all your dependencies, and then you call them in your view functions. And usually you also need some kind of cleanup, so you write a teardown function. Now for a central concept like that, this is really verbose. It has to be implemented for every single dependency. And only those 2 expressions are relevant. The rest is boilerplate. And it also needs a bunch of type ignores, if you care about types like I do, which really bothers me. And it's easy to run into import problems like cyclic imports because the get functions are sprinkled all over your code base. What I like about this is that it is on demand. So you acquire the resource only when you need it. And it gets cleaned up automatically after a request. That's good. It's also somewhat testable because it looks at the G first before it instantiates a connection. So you can beat it to it and put something on G first. So that's nice. But how would this look in services? So we create a connection pool like before and a Flask app. And then we initialize services Flask support. As you can see, services acts like a run-of-the-mill Flask extension, standard pattern. Then we register a factory on the initialized application for connections, and we use engine.connect. Now, what I would clean up, connect is a context manager, and services will detect that, and it will enter and exit that context manager automatically for you. Finally, we add a mysterious ping that uses a connection that is passed into it, and that executes a select one. We will get back to that later. Now, how do we use this in your view? You simply get the connection type, and you will get it. Now, in other frameworks, you will have to pass a request object into get, but for Flask, it services wraps the G object for you. It just abstracts it, all of this for you away. Otherwise, it's the same modulo async. It's all the same in all web frameworks. And as before, you only ask for the connection when you need it, when the form is valid. Like many dependency injection frameworks, either indiscriminately pass connections into your views, which is a waste. What if you don't need it? Or leave the cleanup to you, which is a hassle. And I don't like hassle. So let's briefly talk about the select one from before. It is for health checks. It is very good form for any application that uses external resources to offer a way to introspect them, their own view on those resources. So like the infamous health Z endpoint. And services pings make it very easy to implement that. Like this is how it looks in Flask. I do not have time to explain the whole code, but I built a dictionary of passing and failing services by asking services for all pingable services, pinging them, and then handling the exception and setting the code accordingly. This is great for monitoring. This is great for debugging because the error message is in the view, so you can introspect what's going wrong. And this view, as you can see, it doesn't need to know anything about the services you are pinging because the pings are defined along with the service itself. So you write this once, and then you copy-paste it to all your projects just like I do. Now, there's a lot I had to leave out because Judy is a harsh mistress, and there is so much more. It comes with integration for many, many frameworks. You can register cleanups for at application level 2, so you can dispose the connection pool at the end of your test, at the end of the application. It does the best to make things code type safe. It has full async support, as you can see with the framework support. And I was joking that I had to write a book to explain services, and I kind of did. It's a glossary. Regardless of if you want to use services or not, check it out. There's a good chance you will learn something about software engineering. Please check it out. The QR code takes you there too. Now, if you wonder, do I have stickers? So I wonder, what kind of amateur do I meet?
Thank you very much, Hinek. He has stickers. He wants you to know that he has stickers. Is everything okay? Oh, everything is okay over here. So in that case, I'm going to do a quick introduction. Isaac is going to give a talk called Programming plus Maths plus Video Games equals Mod. Take it away, Isaac. Big round of applause, please.
Thank you very much. Yeah, so my talk's about 3 of my passions and how I've combined them to write a mod. So some stats about me. My degree's in maths. I've played almost 70,000 minutes of Rocket League, level 5 Python, been a Python developer for about 5 years. This is my 4th PyCon appearance. I've drunk 297 unique beers, mostly at PyCon Tiny Rebel, and this is my first conference talk. Thank you. So, in the 4th of January 2001, a game was released called RuneScape. It got pretty popular. It was originally written in Java. Now they have a client in C++. Someone decided it was too much work to play RuneScape all the time, so they created an idle version of it that was released in September 2019. That's had about 500,000 copies sold, and it's written in JavaScript. It's a browser-based game, single player, so modding and the like is kind of up to you. You can do what you want with it. In this game there is combat, so you defeat a monster and you get an item off the table, and some items are rarer than others. This is what it looks like in the browser. So this is the JavaScript. Each monster is a class, so you can find all this by just inspecting in the browser and having a dig through all the JavaScript. This is the class that we just looked at on the other page. So you've got a loot chance, there's a loot table with all the items. They've got a minimum quantity, maximum quantity, and a relative weight. So obviously the weight's smaller on the rarer items. So in the default game, the code is run as written. It picks an item from the array, obviously relative to the weights. I decided that let's do a bit of maths and see, basically, am I getting really unlucky? So, for example, the bronze shield had a 1 in 27 drop chance. So should I be getting it after 27 defeats? Because that seems kind of intuitive. So with a bit of maths and some probability, we can work out that after 27 defeats, you actually have about a 64% chance. So, better than 50, but it's still not guaranteed. After 54, which is twice the drop rate, you have an 87% chance. So it's still not guaranteed. When you're defeating the monster lots and you're not getting the item, that can be quite frustrating. This is known as a dry streak in the gaming community. I was trying to get an item that had a 1 in 610 drop chance, and I defeated thousands of monsters. I was on a really long dry streak, and that was really annoying because I had other things I wanted to do in the game. So I decided to write a mod that kind of tweaks the odds back into my favor. So the mod requirements were tweak the odds in a way to reduce the chance of a long dry streak, but don't eliminate it altogether because it's still kind of a part of the game. I didn't want to cheat entirely, just wanted to sort of fudge the numbers a bit. So this is the logic that I decided on. So just add a small multiplier to the drop chance. This is for items with a low drop chance. But I wanted to implement this as a step function. So instead of kind of like a gradual change, you had a nice sort of sudden change. For the example, this item had an initial drop chance of 1 in 240. After 240 defeats, you'd then double it to 1 in 120, and so on and so forth. This is how I implemented it. This is the code I wrote. So basically, it iterated through the drop table items. It got the number of times that you defeated the monster. It did a bit of maths by doing the count times the original weight, and then it used a ceiling function to get that step function as opposed to kind of the gradual increase. I wrote it, and then I tested it out, and that was what produced this graph here. The numbers were looking slightly nicer, and it basically meant that I was less likely to go on a dry streak for ages and ages because that was quite boring. I decided that this was kind of interesting, and hey, maybe other people might want to give it a go. So I released it into the inbuilt mod manager. And clearly people agree with me because I've got 817 active users with almost 5,000 downloads. So clearly I'm not the only one having this problem. Thank you very much.
Is that you?
Yeah.
Fantastic. First-time speaker as well. I love it when we get a new speaker on the stage. Well done. And you hit the time, which is just the most important thing. I hate having to clap people off the stage. Hey, Nick.
Did you?
So next, we have a talk called Deploy a Simple Python REST Application Using SST to AWS. And I only know your name is Ben from your email address. So if we could give Ben a big round of applause, please.
Hi guys, I'm Ben. I'm a freelance developer. I do Python and TypeScript mostly being React and React Native. I really like serverless, particularly AWS stuff. I also have an interest in the energy sector. The slides are there. That's a link to it. And the GitHub repo is at the bottom. Hands up, how many of you have used serverless before? And keep your hand up if you've used SST. Or put your hand up if you use serverless framework. OK, a few. So basically, SST is a successor, really, to the serverless framework. And it's a wrapper around the AWS, that should say CDK. That's a typo. It's basically infrastructure in TypeScript. So you're not writing stuff in YAML. It reduces a lot of complexity. It's got out-of-the-box, kind of easy-to-use constructs, the most important things. And then if you want to go further than that, you can use the CDK. The nicest thing about it is what's in bold, the live hybrid cloud stroke local debug environment, which is absolutely brilliant. So here's what I've done earlier to set this up. I've set up an AWS root account and an individual account just for this. And then I cloned an example from the SST website. So focus on the left-hand side, the infrastructure. Like I've changed this to be an AppSync rather than a REST API example. Like if you don't know AppSync, I wouldn't worry too much about it. But on the left-hand side, like is everything you need to deploy an API create a DynamoDB table and do all the permissioning for the API to access that. And you can just hit deploy, and you can run it instantly from your developer terminal, or you can put it up into the cloud, in production. And it's simple, it's nice, it does lots of stuff that you would otherwise spend a hell of a lot of time kind of figuring out for yourself, particularly if you're new to AWS. And yeah, then the most magical thing about all of it is there's a command yarn dev. It spins up a local development environment. And what it does is for the Lambda functions, it actually runs it on your local machine. So you can make quick changes to the code and it gets updated instantly. But up in the cloud, it creates the API, endpoints, the domain names, all that kind of stuff, and proxies the requests to your machine. So you can test all the bits about your application that actually require the cloud, and which you can't meaningfully kind of replicate in a local development environment, with all the benefits of the flexibility of being able to make quick changes to the code and for that to be updated, in your IDE and on your local machine. And when you spin it up, you get this URL, and if you put that into your browser, you get this wonderful console. And it has all the resources. So there are 4 Lambda functions, a resolver for each of the queries and mutations in AppSync. Like if you're more familiar with REST API, you could just, that's akin to different endpoints. And then you get the live URL. Now, when I was messing around with this earlier, I threw a couple of errors. And this is actually really quite new, but you get a graph and you can see everything that's happened with errors while you've been running it in dev, which is absolutely brilliant. And then because it is actually running in an AWS account, you can spin up AppSync console and you can run a query, which I'll do. And it's not going to work. Oh yeah, it is. Perfect. Or you can actually have a look at the table. So yeah, that's a bit of an overview. I really would suggest you go and have a look at SST. The Discord community is really good. It's making quite a storm in the JavaScript world. Who knows if it will be more of a thing in Python, but let's see. And yeah, if you want to ask me any questions, my email is on the end of the slides. There you go.
Please. Thank you, Ben. So now I think maybe a slight change in pace. P is going to teach us how to relax our body and mind. Take it away, P.
Hi, everyone. So I'm P, and I'm also a developer, but also I have a pretty overactive nervous system. I get into overdrive easily, which means with time, I have learned lots of tricks and tips for relaxing my body and mind. And I will share those tricks and tips for you, and we will go through a few of them together. So hopefully you will be in a nice and relaxed space for your evening activities, whether it's board games or manual technologies or maybe just a pub. So let's start with relaxing our body through sitting posture. So like many people have like back pain, lower back pain, and often it stems from basically how we sit. And there is like a really simple trick for like which might help lots of you. It helped me with the back pain, is to when you sit, you basically have to lean forward slightly, kind of push your bum out and sit from your thighs. And like then it will like make your spine into correct position. I will demonstrate. So like this, basically, like this. Then your spine is naturally straight, and you don't have to do anything else. It's really cool. It's such a simple trick. And this is the only thing you require your eyes on for this presentation. From now on, if you want, you can close your eyes and relax them a bit because you have done a lot of looking throughout the day. You don't have to, you can just soften your gaze, but if you feel safe to do so, just close your eye, rest your eyes for a few minutes. And next exercise is called physiological sigh. And this exercise tells our nervous system that we are safe, everything is all right. Because often when we concentrate, our body thinks we are in high-stakes situation. But actually, we are not in a high-stakes situation. So to tell your body, hey, you're safe, we can relax, you take a deep breath through the nose, and you sigh out through your mouth like, ah. Okay, let's try this together. Take a deep breath in through the nose to the belly, the chest, full expansion. And now sigh out through the mouth. Ah, yeah. And once more, in through the nose to the belly, the chest, and out through the mouth. Yeah. So this is another hack to tell your body we can relax now. Another one is slow breathing. So if you breathe for like in for 1, 2, 3, 4, and out from 1, 2, 3, 4, and in for 1, 2, 3, 4, and out for 1, 2, 3, 4, and in for 1, 2, 3, 4, and out for 1, 2, 3, 4. This regular slow breathing will also take your body, will tell your body, okay, we can relax now. You can also try, like, if you feel already relaxed and you want to go deeper, you can do pauses at the top and the bottom of your breath. So in for 1, 2, 3, 4. Pause for 1, 2, 3, 4. Out for 1, 2, 3, 4. And pause for 1, 2, 3, 4. And if you repeat this a few times, you can basically tell your body to relax. Even if you practice this regularly, you can basically go from having a panic attack later to calming yourself down through the box breathing. This technique is called box breathing, but it's important to practice when you're calm or just a little bit stressed. Practice regularly. Then if you're like in much more stressed situation, you will remember more instinctively to use this technique. And last technique, which we'll go through slowly, is a body scanner. So we will go through our body from top to bottom, and we will relax our body. So relax the top of your head, your forehead, your eyes, your nose, your jaw, your neck, your upper back, your chest. Relax your belly, your middle and lower back. Relax your shoulders, relax your arms and forearms. Relax your hands and fingers. Relax your hips, relax your legs, thighs, calves, relax your feet. Okay, and now we are all relaxed and ready for the next talk. Thank you so much.
Thank you so much. So here I am trying to keep you energized tonight, stamping your feet and making noise. And, I feel like I've done an hour of yoga. It's fantastic. So Luke is next. I'm guessing you don't have any slides. So Luke is going to give a talk called Multiprocessing with AsyncIO. Can we have a big round of applause, please?
Thank you. I would have happily given up my talk for just 5 more minutes of the relaxation. That was great. So recently I was working on a feature that used multiprocessing, and I coincidentally came across a talk from PyCon 2023 in the US, where Lucas Langer gave a talk on bypassing the GIL. And I thought that was really interesting, and it coincidentally reinforced a lot of the lessons that I had learned. So I took what Lucas had discussed, and I wrote in my own time a generic library for processing a NumPy array and doing it in parallel, utilizing the multiple cores that you may have on your machine. So I used AsyncIO, NEIO, which I mentioned briefly earlier, that despite the bug is actually incredibly useful, and Python's concurrent futures library. So I'm going to mention a bit of a difference between concurrency and parallelism. Lucas gave a great analogy that doing something concurrently is like having a very competent bartender that can seamlessly prepare multiple drinks at the same time, but there's only really one worker. Doing things in parallel is like actually having multiple bartenders. You can genuinely do multiple tasks at the same time. Right, so in Python there is a thing called the GIL, and it stops us from really utilizing multi-threading properly. There is a great meme with this. It's not mine, but I did come across it. So that's what the GIL basically does. So how do we work around this in Python? Well, there is a no-GIL Python implementation that's perhaps around the corner, but for now what we have to use is multiprocessing. That will start a new process to run your code. This is effectively like starting up a separate terminal and running Python on that. Because it's processes, not threads, no memory is shared, so you cannot share state. So given that, how can we share data between the different processes? There are a couple of solutions, but the one I recommend is shared memory, which is available in Python 3.8. So the most common use case for multiprocessing is to increase the speed and the time, the time taken to do an operation by utilizing the cores of your systems to get these other guys to also chip in. So let me give an example of, it's probably really tiny. Hopefully it's not too important. So the library that I've developed will allow you to take a NumPy array with some data in and batch that up and have the cores on your system take each batch and process it. So the data goes in a shared memory block, and then each of the cores on your system recreates that shared memory in the separate process space, takes the chunk of data, processes it, and then there's a callback, and it gives you your results back in the user space. So this library is, I put it on PyPy today. It's very last minute. It's called MPAIO, not a great name. So there are some examples that GitHub that comes with this also has some examples to show you how to run it. The examples are very dumb. It's a NumPy array that contains numbers from 1 to 100 million, and the worker simply just adds every one up sequentially. You could do this in order one operation using maths, but this does it in a dumb way. So if I run the example also produces a data frame that plots the CPU usage, and it's going to take some time because it's summing all these numbers up. But this is essentially what the graph looks like using one process. And that's my time that's gone off. So I'll stop there. But I promise you can use all your processes and do it in a fraction of the time. That's it.
I had 15 seconds left, but that was still, it's very easy to hit that time limit. Yeah. So I will move on quickly. Oh, actually, you're not next. So next, we have, what number were you? Sorry, you don't know. What's the talk? Django the Enabler. Oh, maybe you were next. Sorry, maybe it is 6 next. I've messed up my cards. So anyway, here is Russ with a talk called Django the Enabler. Big round of applause, please.
Thanks, everyone. I feel so relaxed. A couple of years ago, I was approached by Adobe to come and join them as a technical consultant. I had spent some time in Germany. I spoke German fairly fluently, and they had lots of German customers who needed help with their sign electronic signature product. And I got involved in that. I learned the product, I learned the customers. I spent some time with some very interesting German customers, quite big names. Everybody here will recognize all of them. And then I was approached with a problem that was to do with migrating some customers' assets into what was then called Adobe Sign. Now it's called Acrobat Sign. And we did some experimentation for which I made a switch. I went back to Django, Postgres, and Docker, which are the tools I've been using for a long time now for development. And that's a way of life for me. So it was like stepping back out of this kind of new world of dealing with lots of random people's kind of random problems to being back developing software for cool problems. And here I was. So why Django, Postgres, Docker? Why do I like those? Well, these are pretty good reasons. It's a great way of solving lots and lots of problems. It's an environment where you can easily make command line solutions, where you have access to database, and of course you have access to the web. You can make HTTP stuff, and you can do some really amazing stuff. You also have a great tool for dealing with things like database migration, evolving the database as you go. So it's just a great system. We began a 26-month voyage, and we're still going on that voyage. And these are some of the features that really I find very, very persuasive towards using Django overall. In our application, we used a lot of libraries, but a lot of diversity in what we've done. Parsing, polymorphic objects, multiprocessing, and PDF manipulation. We talked earlier about Django HTMX. We do that in our application. We do a lot of stuff with Zope page templates. Zope was mentioned earlier. And we've used all sorts of interesting libraries, including Selenium, which is a way of driving browser interactions. In other words, it's a great way of testing. And we use PyTest extensively for a lot of unit tests. But I went there for a 2-year engagement. That was extended for a year. That will come to 3 years. External consultants don't stay at Adobe for 3 years normally, so I'm being kicked out. So I need to find a replacement for me. And I'm here doing it now. Is anyone interested in working on this project in this kind of environment? There are 2 positions. If you're interested, take a picture of the screen and speak to me later.
Fantastic. Thank you, Russ. There's definitely some shuffling of cards there. So the next talk is going to be on this side. Michael, if you'd like to get set up over here, that would be fantastic. And now it's my great pleasure to introduce Alex Willmer, who is going to talk about Kendo, the martial art of hitting people with a stick. So a big round of applause for Alex, please.
Good evening, EuroPython. My name's Alex, and I like playing dress-up at Python UK. So, the outfit you see me in tonight is the gear for the Japanese martial art of Kendo. For Kendo, we are trying to hit each other with this, the shinai, which is a simulation of a katana, a Japanese sword. It's made of bamboo, 4 slats in a circular arrangement. It's hollow, and the idea of it being hollow and bamboo is that it dissipates the energy and it breaks before somebody more important breaks. Because we want to be a bit more safe than that, in addition to making the shinai more fragile than it might be, we also wear this protective gear. The protective gear that you can see me in, overall is called bogu. The parts of it individually are these gauntlets called kote, the face mask, which is open at the back and has a steel grill at the front. This is the men. And finally, around my torso, I am wearing a do, which is made of, in this case, resin and is fairly stiff. So the reason we wear these is because those are the places where we get hit. The standard stance for Kendo is with the shinai like this, and the standard cut is a men cut, which would be something like this. Men! We are aiming to hit the forehead here, where there is the most protection, and the sound you're looking for is a knock here, as opposed to a metallic clang that would come from here. The other hits that we can go for are to go for the kote, which again, you call your strike as you do it. So, kote! And what we are looking for is a quality called zanshin, where we are showing the cut that we have made and showing a fighting spirit. The final positions that we can cut are to either side, just below the ribs. This is called a do cut and would look something like do, which can be done on either side. Finally, there is one more cut which would be unavailable to me at my current grade, which is a Q grade. This is a very basic grade that in Japan people in high school or secondary school would be getting. If I were one grade higher, then another attack available to me or to my opponents would be a thrust to the neck, something like that. But because of the higher risk with it, it's only open to higher grades. If anybody would like to try Kendo, please find me. I will be about tonight. I will be about at the rest of the conference. If you are in the Reading area, then the club, the dojo at which I practice, is starting a beginner course in the middle of October. Other towns and cities have their own clubs. There are many in and around London, if that's where you're from. Certainly in the London area, some are open to children as well as adults. And I would like to thank you for your time. Thank you.
Thank you. Thank you, Alex. I've known him for many years, and he's always been a very gentle and mild-mannered individual, and now I think I know where he's taking out his aggression. So moving on, I'd now like to pass the stage to Michael Foord, who is going to talk about metaclasses in 5 minutes.
Hello. This microphone. Hello, everyone. My name is Michael Foord. back in the distant past, I was the original author of unittest.mock and looked after unit test in the standard library. And when I started with Python, metaclasses were considered deep black magic. In fact, Tim Peters, who is the author of the Zen of Python, with some beautiful and philosophical advice on coding in Python, said that metaclasses and descriptors are considered black magic in Python and not needed by 90% of people. And like all black magic, I consider them to be useful for understanding the world, but never to be practiced. Who feels like they understand metaclasses? I think the knowledge is much more common than it was when I started with Python. Some of you, so my goal is to teach you metaclasses in about 4 minutes and 30 seconds, which means I'll probably have to talk quite fast, I'm sorry. So I teach Python, I do training, Python and advanced Python. My email address and URL I'll try and recycle at the end, and I'm looking for contracting work. Right, so one of my mantras when training is everything in Python is an object. Every object has a type. You can only perform operations appropriate for the type. Python has a type system. It's a dynamic type system. And it's the type that's responsible for creating new instances. So everything is a type. And this leads to the wonderful why I fell in love with Python, is that the type system gives us these two features. Python object is an instance of itself. And the type. Oh, it's hard to type when in front of so many people. Type of type is type. And this provides us a consistent worldview for a logical framework within which we can build things. So if everything is an object, then if we create a class, this is an object. So if it's an object, what is its type? Well, class and type are synonyms in Python. We tend to use the word type for the built-in types and the word class for user-defined classes, but they're exactly equivalent, and classes are types. And in fact, if you remember, types are responsible for creating instances. It's type that creates classes at runtime. Now, this is perhaps the useful bit of the class, of the talk. So we can actually use type as a class factory, just as you can build factory functions using closures. You can build factory functions that create classes, class factories. And so type in its 3-argument form. It takes the name of the class. It takes the bases for the class. We're going to provide an empty set of bases, which means inherit from object, and the body of the class of a dictionary, everything in the class body. So let's do dict hello equals hello. You can see I defined that as an instance method that takes self. And that actually creates a class for me. And we can instantiate it in the usual way. We can call methods. So using a closure, and using type as a class factor to create classes, you can build classes at runtime, and this is often a useful thing. Name tuple is an example in the standard library. So classes are instances of type. Type creates classes at runtime, so type is the default meta class. Now, we can override this. We can provide custom meta classes, but you shouldn't, although you've possibly used them. If you've used collections.abc, you've used the wonderfully useful collections.abc.sequence or .mapping or mutable mapping. They're great for do type checks against the abstract base classes rather than strict type checks. Inherit from sequence if you're building collections are really useful. And there's a meta class under the hood doing some of the heavy lifting there. If you've used typing, you've used meta classes. The problem is meta classes are very often incompatible. They don't play well with each other. This is why we avoid them. And there's a couple of ways. So types create new instances. And actually, I'm going to save on the typing here and show you. Here's an example of a meta class. And this is the syntax for using them. We inherit from type. We can get involved in class creation. So when we create a class, you can see that I'll create another one. In fact, let me show you the lovely thing about, and a big part of the problem, one of the reasons why you might not have seen them is that they're inherited. So I create a new class that inherits from foo, and my meta class is called to create the class, and we get the name of the class, we get the body of the class Actually, I've swapped around bases and body, haven't I? That's incorrect. It's bases and body. I'm sorry, very embarrassed. So you get a chance, you can inject things into the inheritance hierarchy. You can wrap all the functions of the class. You can add new methods. There's also a double underscore prepare double underscore where you can return the class dictionary. You can have a custom object that is going to be used as the class dictionary. So we can get involved in class creation. There's another method, class decorators, a couple of wonderful ones in the Python standard library. Functools.totalOrdering. If you implement the less than and equality methods, functools.totalOrdering will mix in all of the other comparison methods for you. Dataclasses.dataclass, that allows you to define and build really simple classes, and it will give you an initializer and a repra and equality methods for free. And those are called at class creation time, but they're not inherited. So what I'd like to do is show you one, and if you want something that's inherited, the done in its subclass method, very powerful. Let me show you, if I can. Do I have time? I'm going to race. Oh, I don't think I can do it. I should have done this before, shouldn't I?
Is this the last line of code?
One before last. Okay, let's do class foo. We'll use this meta class. So the special methods are looked up on the class object. There's a fast path in the interpreter. So we can implement special methods on our class. So here we have a subscriptable class object. There are still some use cases for meta classes.
And
that's one of these.
Nearly 5 minutes. Very good. So, next, we're a bit out of order now. If we could have Brett setting up over here for the next talk. Brett, could you wave at me? Excellent. Right, and then I'm going to hand over to Eli to, actually, I don't know what you're talking about, so take it away.
I'm talking about punch cards and Jacquard looms. I'm going to talk about how fabric gave us computers. So here we've got some linguistics, we've got some etymology. English technology and English textile are cognate. If you go through the Proto-Indo-European, hands up who's a linguistics nerd in this room? Yeah, there's a smattering, yeah. So this makes sense, right? Because for a long time, the human problems that we had were like make enough food so that we survive, find enough shelter so that we don't like die of exposure, and have enough clothing and ships, sails for our ships and bedding and whatever. And that means textiles. If you look at medieval manuscripts, you'll often see women with drop spindles. This is a woman with a drop spindle and a weird little cat creature who also is trying to get involved with her spinning work, which is great, because if you do yarn crafts and you have a cat, you know this is exactly how it goes. And you will see women with drop spindles in the marginalia of loads of historical manuscripts. And this is because if you were a woman in like the 12th century of Europe and you had 5 spare minutes, no, you didn't. You had to spend it spinning yarn. And this is actually where we get the phrase to spin a yarn, meaning to tell a tale, because women would sit and spin and tell each other stories, much like we sit and listen to podcasts now and like we do our little craft or whatever. They didn't have podcasts back then. They had to tell each other stories, so spinning a yarn. And humans like fabrics. We like fancy fabrics. And it was much, much easier to create fancy fabrics when we discovered, when in 2nd century China, looms were invented. And this makes the process of creating fabric much, much easier, which is great because we need a lot of it. And yeah, we like fabrics. This is some nice fancy fabric. What we really, really like are things with lots and lots of patterns, because if we can have something and we can have something be fancy, that's even better. And when you create fabric with a loom like this, what you have is you have a bunch of threads that run up and down, and you have a bunch of threads that get passed through side to side. And every time you pass the fabric, the threads that go from side to side, those are the weft threads, and then you have the warp threads, which are the ones that run up and down. Every time you need to do some weaving, weft weaving, you have these threads that come up and down, and you need to separate them, and then you pass some threads through, and then you swap them, and then you pass it back. If you've got lots of different colors of thread, you can make very fancy patterned fabrics by choosing very specifically which ones go forward and backward at which points. Now, picking threads in order to make that fancy fabric pattern happen is very, very complicated. And it involves do I want this thread or do I not want this thread? Do I want that thread or do I not want that thread? For every single thread in your loom, for every single pass. This is very error-prone if you have humans doing it, and it used to be done manually. What if we could automate that process of saying, I do or do not want this thread to be picked? This is where we get Jacquard looms. So what these do is you have a bunch of punch cards, and for each pass of the weft threads through the warp, which has been separated, the separation is done by a load of little hooks, one per thread, and they come down and they try and pick up the thread to separate it, to create the gap in the warp threads. And if there's a hole there, the little hook can come down and grab the thread and lift it up. If there's not, it's blocked and it can't. So you can automatically program which threads get picked up and which ones get left behind to program color information into these physical objects. These are punch cards. And so with this, you can create lots and lots of fancy patterned fabrics. This is some silk brocade. It's not ancient. This is from 1963. But you can create lots and lots of really beautiful fabrics with much lower error rates and much lower rates of human labor involved for much, much cheaper. And this is great. It also gave us computers. If you go and look at the very earlier history of computing, I'm sure a lot of you know this, early computers developed by Herman Hollerith, originally used for the 1890 US Census. All of that data was collated on punch cards. He founded a company that later went on to get merged into what would become IBM. So actually, this is a very, very early computer. This is data storage from, I think it's like the 1860s. I think that's very, very cool. And it also ties really nicely back into this fact that, technology and textiles have always been really closely related. That continues on to the current day. I think that's really, really cool. This is part of a larger talk I have about the history of data storage. Come past to me for the YouTube link if you're interested in knowing more about it. Yeah, cool facts, cool history facts. Everybody should know them. Thank you.
We're running a little bit over. I think we're going to finish at quarter-past. If anybody thinks that's a terrible idea, could they kind of make waving motions at me? No? That's excellent. So now, because we get Bjarni setting up over here. Fantastic. Bjarni's going to be our final speaker of the evening. We have our last two speakers, so if we keep the energy going, that last round of applause was fantastic. Bjarni is going to be talking about custom AI dog art of your dog, in brackets. So if you'd like to take it away, quick round of applause, please.
Hey! Hello. Okay, hello, check 1, 2, hi. So this is something I've been working kind of nights, weekends sometimes on, that was motivated by, has anyone here worked with like Midjourney, Stable Diffusion, these image generation models? Can you put a hand up? Okay, that's like less people than I thought. It's really fun. You just typically type in a little prompt and then you can kind of create images to your imagination. One thing that's kind of limiting is I wanted to start like putting actual subjects into those images, and one was my sister's dog, Lua, named not after the programming language, but the moon. Lua is cute, to me at least. She's also very loud, she's very expressive, and she doesn't like unknown things. I have a video of her barking at an avocado for about a minute straight, just because she'd never seen one before. But I'm showing you these images because these, I think there are about 8 images, are what I use to train a model, which is a Stable Diffusion model. And then after that, I was able to make custom art of Lua, which I will try to pull up right now, in the style of Art Nouveau. And these are a couple of examples. And this is just the first batch. I started to get really creative with it. I don't have the examples in front of me, but I started making her a disco dog, so 1970s Lua, and it would give her a big beard. It was really funny. And the technique behind this is called low-rank adaptation, or often shortened to LoRA. I don't have slides, by the way, so you're going to have to deal with like the Apple Notes app. There are other fine-tuning alternatives that you can look up. They're called Dream Booth and textual inversion. But at the end of the day, what happens when you train it with LoRA, and the reason that a lot of people do it, is that it's kind of like a series of weights that you can like package up and carry around and layer onto the model later. And it's fairly like low, it's not as intensive as other methods, and it can be cheaper. So LoRA, at a high level, what it does is I gave the model like 8 images of Lua, And I told it, like, this is an object, Lua, and I want you to associate a specific token with this object. So by default, it's just TOK, T-O-K. And once it does a little training session on Lua, it knows that anytime I use TOK, that I'm referring to Lua, and then I can start getting creative with things. So what I used is a service called Replicate. This is replicate.com. The total cost of training the model is about 50 cents, like 40 cents in US dollars. And there's extensive documentation on their website on how to do this. And generating images is insanely cheap. I think I've generated like 1,000 images. And it's like up for under, I don't know, $5 or $6. So if we can maybe try, let's see here. So this is the model that I created on Replicate. Well, maybe I'll do a tiny thing. So you would just go to the website, click Create Model. They even have like something right here. You would select that you're fine-tuning SDXL, which is Stable Diffusion. And then you can just write a simple script to upload the photos that it needs to train on. And it's really kind of that easy. Afterwards, you can either use scripts or their web UI to create images. So could anyone just yell out an artistic style? Pointillism. What was the other one? Okay. We'll try a painting of a talk dog in the style of Picasso, influenced by pointillism. I don't know how that's going to look. There's this thing here called a negative prompt that just means like you influence the model to not include like a frame, because if it says painting, sometimes it thinks you should include a frame in it. And let's see here. For the sake of, so I'll do fewer outputs. And let's see here. Do I need anything else? No, there are some additional things you'd want to tweak. Talk to me afterwards if you want to do this. I can show you how. And so I'll submit this. This will take a little bit of time, during which I'm going to, okay, so it's not, this is a plug for my Instagram. I have 20 followers, everybody, 20 followers. I've been posting some of the art on Instagram under the handle Ink and Fur. You can see how goofy it gets. Oh, yeah, this is Disco Lua. It's kind of hard to see, but the model turned her ears into like pom-poms, I don't know. And if we go back, oh no, it has to cold start the model, so this might take longer than the demo. I should have prepped better. Okay, well, that's enough. I'm done. Aha!
Thank you, Brett. Thank you, Brett. My brain turns to mush whenever I step onto the stage. Did I call you Bjarni when I introduced you? Because I know I was getting you onto the stage. Yeah, that happens. It happens when I'm not on the stage as well. Well, I'd like to welcome our final speaker of the evening. This is Bjarni. Am I pronouncing your name vaguely correctly? Perfect. Oh, wow. OK. He's going to give a talk called Yay, Zip Files, with 3 exclamation marks. Big round of applause, please.
So I figured if I'm giving a talk about 80s technology, I should do an 80s style presentation. So this is done in Vim. I realized something just as I got on stage here, is that last time I gave a talk, which was a lightning talk in a text in an editor, that ended up being a 6-7 year project that I'm not done with yet. So wish me luck. So the inspiration for this talk came from a hackerspace. I'm in a hackerspace in Iceland, and someone shared this meme in our little Signal chat group. And I look at it, and I'm like, that's me. This meme is about me, and I think you should all be just like me. So they're not shaming the guy. He's doing the right thing. Zip files are wonderful. So I went to Wikipedia. How many people in here don't know what a zip file is? No shame. It's really old, but it looks like you all know what they are, so we can kind of skip this talk. But the Wikipedia article about zip files is actually great. It has lots of really interesting information. So if you have nothing better to do, go read it. It's wonderful. But the format's from 1989, and we're still using it. The structure of a zip file is part of why we're using it still, because it's really, really simple. It's basically just, a zip file contains a bunch of other files. You have a little header, and then you put the file, Maybe you've compressed it, maybe you've encrypted it, maybe it's just there in the clear. And then you put the next file, and then you put the next file, and you keep doing that until you're bored, and then you write a table of contents at the end. And that's the whole thing. And that means that when you want to add something to the file, you just figure out where's my table of contents, chop that off, add some more files, write a new table of contents, and you're done. This means that it's very easy to seek back and forth. The table of contents tells you exactly where the data is, so you can go back to the beginning, you can find everything, which is very different from other archival formats like tar. Tar will give you a stream of files, and each file tells you a bit more about itself. But to get file number 23, you have to read all the files before that, because you don't know where it starts. So, we could write something to create zip files that looks a bit like this code, but it's probably better to import zip file, because support for zip files has been built into Python, part of the standard library forever. And that looks kind of like this. You can either do it programmatically, you can create an archive and then just write data directly into it, or you can read files from the file system. There are a bunch of convenience methods that will gather up entire directories and put them in there for you if that's what you want. But weirdly, there's no way of deleting anything from the zip file. That hasn't been implemented and isn't in the standard library, which is one of those little gaps that if anyone knows how to interact with the Python community to get that fixed, I would actually like to fix it. I'm contributing such fixes to a different library because I want to use zip files as a relatively standardized secure container format. There is no other format of files which I can give to you on any operating system with an expectation that you'll be able to open it and read it as a general user. So there's this project called PyZipper, which is basically the standard lib zip file from, I think, Python 3. It might have been 3.8, I'm not sure. He forked it and then started adding the bits and bobs that he needed to implement WinZip's AES encryption, both for decrypting and for encrypting. So you can create files that have strong crypto. It's not perfect because the table of contents, the central directory as it's called in the technical jargon, is not encrypted. So you're leaking a lot of metadata, but it's still better than on most other things. We don't have a lot of standard encrypted file formats. That's why I'm interested in it. And I've added support for deletion to PyZipper and just waiting for the pull request to be accepted, maybe. We'll see. So the reason I'm standing up here is just to remind you that zip files are awesome. There's support for them on all of the operating systems. And this gets back to something that I really care about, which is sort of user accessibility. Like if we're writing tools for our users that manipulate data, they should be able to get at their data without our tool. And that's a concept that people don't talk about much because we're not necessarily writing tools where people run them on their computer and create data, but some of us are, and it's really easy to fall into the trap of not being this guy and creating your own custom file format. And that means if your tool succumbs to bit rot and goes away, or people just decide they hate it because you did a terrible job, their data's trapped. So if you can use a standard container, like a zip file, or something else, there are other standards out there, by all means, do.
Thank you, Bjarni. Well, that's the end of our lightning talk session for today. We have 2 more lightning talk sessions during the rest of the conference, so please submit more talk proposals over the next 2 days. The buckets will be by reception. If you would like to give a lightning talk but don't really know where to start, or you just want some time to work on your lightning talk, we're running a workshop at 11 a.m. tomorrow in the classroom. My name is Mark Smith, and I will see you there, and I'll see you later. And I'm actually going to hand over to Anne. Thank you very much, everybody.